This is my long YouTube video. The topic of my final project is data time series forecasting. So the aim of this project is to create and implement a trading rule on Bitcoin. In order to achieve this goal, we first create a criteria to assess the fair price of the asset by running an ARIMA model using historic price data. Then we downloaded real-time data from a cryptocurrency exchange to contrast our price target with the market price. The output of this contrast is the trading recommendation. In order to process the data and output conclusions, we use two important Python packages. Stats model enables the user to run ARIMA models and compute Bitcoin's fair price. And request is used to contrast it with real-time data. Finally, we thought it would be useful to store in HDFS the online data in order to be able to update the model periodically or even daily. So this is the data set we used to run the model. It was downloaded from Twitter and it contains time series of a variety of cryptocurrencies. Of course, we picked Bitcoin because that's what we are estimating. So in order to run HDFS, we had to install Cloudera virtual machine in our by using VirtualBox. This is the URL we used. The downloading and the installation is pretty straightforward, and we had no difficulties in doing that. So before working with HDFS, we should run Hadoop and Yarn already installed and we should have Hadoop and Yarn already installed and running. In order to do this, we type in the shell these commands. So once we list Hadoop services and start them running, we can create and add files. We can create a directory in HDFS and run files. And well, this command down here is the one we use to create this directory, which is where we are going to finally store the data we download from the online data, the real-time data we will download from the cryptocurrency exchange. So once we are done with that, we have to install Python 2.7 in the Cloudera virtual machine because the one that comes within is Python 2.6. The reason why we do this is that we need to install a variety of packages that we will use to analyze our data. So otherwise, if you try running installing these packages and running them with Python 2.6, you come across an error message. So this is the way we were able to deal with that. And here you have the list of commands you have to follow step by step in order to get everything running. So once you have Python 2.7 running, you can download and install pip. And once you have that, you can install all the packages we are going to use to run our ARIMA model and get our trading recommendations. So once we're done with all the installation, we start analyzing our time series. So what we first do is to get a chart of the Bitcoin price. And of course, what we find out after carrying out a Dickey-Filler test is that the Bitcoin price time series is non-stationary and it has one unique root. To give a simple idea of what we mean by this is the ARIMA model works with stationary series, and that's the model we're going to use to estimate our Bitcoin fair price. So we will have to do something about this in order to be able to run our ARIMA model. So what we will do is we will render we will render our time series stationary, and what we do by this is to work with stationary series. So by stationary, what we mean, to have an idea, is that variables converge at some point in time to their mean. So by doing this, we have some kind of guarantee that the parameters or the weights that we estimate are stable over time. So that's the idea behind working with stationary series. So to do this, we compute the log difference of the Bitcoin price. And once we carry out the Dickey-Fluid test, we find out that this new time series is stationary. So voila, we have a new time series, stationary, and now we are ready to estimate the ARIMA parameters. So in order to do this, we run the autocorrelation, a partial autocorrelation function, which suggests that the autoregressive component and the moving average component are of order 1. So having said this, and bearing in mind that the Bitcoin price has only one unit root, we have come to the conclusion that the parameters that go with our ARIMA model are 1, 1, and 1. So now we are ready to estimate our model. And this is the output of our model. The R-square is 0.9733, which is quite high, close to 1. So we are ready to compute our out-of-forecast target price. The output we get is 2,000, close to 2,400, which when we compare it to the online market price we get from the exchange, is quite below. So the recommendation we get is to sell. So after doing this, what our code will do is to save this data in a file named data.txt and save it in the directory we created before, which is final p. And by typing this command in the shell, we can see that our file is there. So anytime we want to work with it, we just have to download it and just update our database and run again our ARIMA model, compute again our target price, and that's how this code works. So someone could be interested in knowing why we didn't use Spark. We did try using Spark as a first approach, but we came to know that Spark doesn't have a time series package a package to analyze correctly time series. So we had no other choice but to use Python's Python's packages, state model, and request, basically. And of course, last but not least, there are two things that we could do to improve this model, which is first is to use more recent data. The data we're using is up to June 2017. And as you may know, Bitcoin price skyrocketed, and so it's so the fair price we get is quite not updated. So we should do that. And another way to improve our analysis would be to include our other explanatory variables and run error vector correction models. But this is far beyond the scope of this course, so most probably we'll try this a little bit later. So hope you guys found this interesting, and hope you like it.